Mm. All right. Hopefully, this second rendition of the stream works out, because if it doesn't, I'm gonna be real sad. Be real sad, Jim. See what we got here. All right. We are live again, allegedly. See how long it lasts. Pop out chat. And bring Jim over here. The chat over here.
Here we are.
And we're good. All right. Okay, so kind of got sidetracked right when we were about to get into the intro of the show and start kicking things off, but let's do a quick reiteration. So we're going to talk about sprites and elves real quick. Jim's never heard of it, and it's a really interesting subject that that Bob Nodell kind of figured out and put forward as an with his explanations. And I'd like to present them to Jim and anyone else who hasn't heard of them. So what are sprites and what are elves? So sprites and elves. All right, welcome back, Rebecca, for the second time. This time it should be permanent, allegedly. We're really hoping that it sticks this time. Welcome back, Rebecca. Okay, so Jim, there's this, fuck. Screen share it with you. Hopefully this doesn't lag too much. It's an elves. 720p. All right, if it starts lagging the YouTube, I'll have to close it, but you should be able to follow along with this.
Yeah, right. Yep.
All right, cool. Got us on the trio screen. All right.
It's the same thing on YouTube.
Okay, cool. So there's a lightning phenomenon, right? Where these red rings appear in the sky and then these downward discharges. So the red rings are called elves, I believe, and the red discharge going down is called the sprites. So sprites and elves, essentially. Apparently the guy that discovered this phenomenon recently was super into D&D, so that's what they went with for the naming of it. Sprites and elves. So what's possibly creating this? So Bob Nodell kind of put this forward. So there is we know about the static electric gradient, which we'll do a quick demo of it here. Corona motor. So this is a quick video of a guy using a Corona motor, which is using the static electric gradient potential in the air to power a motor. And basically what's going on here at the surface, when you're standing on the ground, you're negatively charged, or you're not, charging, or you're discharging, right? So zero potential here. And then as you get off of the ground, 100 volts per meter, equidistant potential lines, they call it. So in other words, linear horizontal lines that go up in a gradient. Every meter, it goes up by 100 volts. So by the time you get up to, forget what it's at 50,000 meters, but it's like 50,000 volts or 50 million volts. I forget what it is, how it scales. 100 volts per yard, I think it was. Anyway, there's two ways to express this gradient, and one of them is spherical, and the other one is what's known as like a Gaussian surface. So there'll be two flat plates, essentially. One plate is discharging, and the other plate is creating charge, right? So in positive and negative in terms of the model and how it's usually described, right? So
is that your Gaussian surfaces you're talking about?
Yeah, so like a firmament, and then the surface of the Earth would be where there's discharge, right? So the surface is creating a higher electric static potential, and that gradient, is going all the way down to the surface. So what's happening up here at this highest potential, where there's all this excess static electric energy being generated, it discharges downwards from the top, right? So what's really interesting about that is you would think that it would be like coming from a cloud or something and it would discharge up, but it doesn't. It comes from the top down, and then there's also these rings that form across the top, as if it's a horizontal surface up there with a bunch of static electric potential. So the discharge seeks equilibrium, so it goes down. It's trying to seek the a place to discharge. So that's why it's coming from the top. So this top surface is, holds all the charge potential, and that gradient is what creates that static electric gradient that we say creates the downward bias. And it's like, does it create a downward is it like pulling on you and shit? No. It's just a directional. It's just like, this is up, this is down kind of thing. It's not in the same regard as like, is it pulling you kind of thing. So that's Sprites and Elves, Jim. What do you think about that?
And that's basically the replacement for what you measure when you step on a scale. It's not gravity that caused you to be 180 pounds. It's this electrostatic downward.
Well, that would be like a density buoyancy situation facilitated by the directional vector provided by the static electric gradient. So it's like a combination of the two, because the density buoyancy isn't enough to do it, right? You need the downward bias, and that's where that comes from. So it's literally a high charge seeking equilibrium with a place to discharge with the surface of the Earth.
And that's what you and Austin talk about when you talk about Gaussian surfaces.
Indeed, yep. And that was first presented by Bob Nodell, who pointed that out. And in this book, if you watch the video, I'll put a link in the thing for anyone interested. So this is the guy that does the corona motor thing, if anyone's interested in that. But when he pulls out the book, when he's flipping through it, there's two equations that they use to describe a Gaussian surface. So there's a Gaussian surface that's a sphere, which there's not equal distant potential lines, so it doesn't scale linearly, right? It like falls off at like a weird curve because it's on a sphere, right? So different equation, and the one that they use for Earth, right, is the horizontal one, specifically not the spherical one. So if that's any indicator of where we live, it's a plane, right? Essentially.
Yeah, it can explain what's possibly above us, which can be spherical, and then it just grabs what's below us, which is horizontal.
Yep. So that's how that works. So anyway, yeah, that's the equidistant static electric gradient that's in our atmosphere every day that we're standing on, walking through, all that shit, and that's what creates that vector.
It's awesome. I think a lot of people that helps us, as we're going to do in future podcasts, that helps us get away from gravity. Absolutely.
Yeah, I mean, well, it helps provide an explanatory answer to it, right? Because we don't deny that things fall or whatever. We just deny, or not deny, but what's in contention is the cause, right? So
exactly. I mean, everybody agrees upon 9.81 meters per second squared, agreed upon average. Which is the effect of things falling to the ground. We just differ on the cause.
Exactly. So we will now get into. You want to do a little Dayton Millie?
Let's do some Dayton Miller, who confirms Michelson-Morley or Michelson-Morley.
Yeah. Well, that's still that's up for debate or whatever, So we'll see how it goes. But yeah, allegedly. So a new crucial experiment for relativity. This is a paper written by Steven Zinz, October 25th, 2012. And this guy covers Dayton Miller, Maurice Elias, and all that kind of stuff, and their analysis is that they conducted. So we'll see what this gentleman has to say about all of that. So abstract. Dayton Miller performed an experiment in 1925 to 1926 that at face value contradicted relativity theory. The strongest argument against Miller's experiment is that subsequent Michelson-Morley experiments yielded increasing consistency with relativity, disagreeing with Miller's results. But subsequent experiments were not valid replications of Miller's. Specifically, they failed to replicate the medium in the light path and the scale of Miller's experiment. A valid replication must either be exact or demonstrably equivalent with regard to the crucial sensing region. The unexplained effects seen by Miller demand demand exact replication. Yeah, the unexplained effects. So the unexplained effects that this guy is talking about, which I kind of skimmed through this earlier, he doesn't mention that his unexplained effects are a correlation with the fringe shift pattern reaching its minimum and maximum dimensions in accordance with the equinoxes to the fucking day. So that's why they're saying like this is a direct refutation to relativity theory, because it measures the rotation of the ether or the sky or whatever's translating that motion. It measures it very accurately to the day of the equinox. And this dude did 30 years of observations. I think he did about either 200,000 or 400,000 Michelson-Morley experiments in total during that 30 years. So, homie put in work. And then I can science that pointed out an interesting argument that he was saying that Dayton Miller was just trying to produce a ton of data so that he could then extrapolate effects, in accordance with whatever he wanted, which is an interesting point. But they also, and at the same time, the mainstream scientific paradigm, or whatever people will use, like what is it called, the law of the crowd or whatever, where the more people that can give input to a problem, it gets more accurate, right? So like when you're trying to guess how many jelly beans are in a jar, if you have 100 people guessing, if you add up all their guesses and divide by 100, I think like that's supposed to be more accurate. And then if you add like 1,000 people and do the same thing, each time you do it, it gets more accurate, something like that. So like there's definitely benefits to having a wide range in or having a lot of data, right? And then also if you look at the scale of data collection that goes on right now, and building algorithms and marketing and all that stuff, it's all about data, maximum data. And when you look at the parallels that the algorithms draw, where they connect like marketing data with your personal data and all the stuff, like the connections that they make for products that they recommend to you, like aren't immediately obvious, but like they hit them, they strike gold, as they say, more often than not with how they do it. So I would argue that more data isn't necessarily a bad thing. And then also there's a lot of noise in these experiments, they say. So the more data you could, apply different analysis strategies to analyze that. And, you can filter out what's noise, when you have a larger data set to figure out, what's what with. So that's the scale of what Dayton Miller presented to physics and science with his experiments. That's what he dropped off on the table: 400,000, Michelson-Morley experiments. So, so to continue on here, the proposed experiment is crucial for special relativity. The unexplained effects seen by Miller demand exact replication. The proposed experiment is crucial for special relativity, but is more than replicable, but is more than a replication of Miller. This proposed crucial experiment should use a Michelson-Morley apparatus with a 4.25 meter arm length, as Miller did. The novelty of this experiment is that the light path should be in a chamber that can be operated from a near 0 to 1 atmosphere. Oh yeah, so this guy proposes, that's what this was. So this guy, he's analyzing the exact conundrum that me and I can science that are in right now, and this guy has a proposed solution to it. So we're gonna get into that.
Mm-hmm.
That's what I skimmed through it, like I said, but I don't really remember the specifics. So this dude's saying, we got to make sure it's analogous and we got to come correct, because this is a really important experiment here. Very pivotal, very to both belief systems, heliocentric and geocentric, planar Earth, that kind of shit. So predictions. At one atmosphere, the result will agree with Miller and contradict relativity. 2. A near zero atmospheres, the result will agree with George Jews and agree with relativity theory. I forget what Jews' experiment was, but it also gave a null result too. These guys all give null result experiments, and then like they mathematically extrapolate relativity from it. It's crazy. Intermediate pressure will yield intermediate results. Okay, so this dude's saying in a 1 atmosphere and then no atmosphere. So in a vacuum, it will be the same. And if there's a medium, there'll be a slight change. All right, background. Origins of ether. Maxwell's formulation of electromagnetism in 1860 described the wave motion of electromagnetic radiation, including light. The medium that was assumed to transmit the waves was called ether. And this was important because they modeled this after the concept of classical wave mechanics, and classical wave mechanics is modeled after acoustics, where a wave is going through a medium. So the acoustics, the sound, with sound, the medium would be air and water vapor. So they assumed it. So they're like, okay, if it's a wave, there has to be a medium. So they came up with this ether, and then the wave would move through the ether, causing an excitation. That excitation would produce the illumination, the visible light spectrum that we see, and all that good stuff. So that's why they came to that conclusion. Second, got a burp, but I'm trying to work it out without. Excuse me, apologize. Let's see, 1.2 experiments. The Michelson-Morley experiment was a test of an ether theory. Well, see, even this dude gets it wrong. So let me just get through the whole thing before I jump to conclusions. The Michelson-Morley experiment was a test of an ether theory, specifically to determine the velocity of Earth through an ether assumed to be fixed in the solar system. So they were assuming a fixed ether and the Earth moving through it, but how he specifically frames it is that this was an ether test. It was a dual purpose test. The motion of the Earth and a potential model of the ether where it was stationary, right? So that's where they're at with the Michelson-Morley. So Michelson-Morley in 1887 measured a velocity certainly less than 1/4 of the orbital velocity of Earth, which is 30 kilometers a second. So that's where we're getting that 8 kilometers, that 6 kilometers a second. That fluctuates. Actually, I think it was, what was it, between 8 and 10 or something like that. I forget what it was. But anyway, there's this 8 kilometer per second drift that doesn't go away. Their experiment was a refutation to the theory of ether. Now, see, wasn't a refutation to the theory that the Earth is in motion, just the ether. After years of preparation, Dayton Miller of Case conducted an elaborate Michelson-Morley experiment, taking data in 4 time periods in 1925 to 1926. The results were similar to the 1887 test, but with a smaller probable error. Taken at face value, it both refuted the ether theory and relativity. How so? How did it refute both of them, though? Oh, with stationary ether. Okay, yeah. Oh, that's right, because they were all fucking ball lads. Okay. So that's how he's interpreting it. Okay, so it refuted both theories of, yeah. Okay, many similar Michelson-Morley experiments have been conducted from Jews in 1930 to present, never producing Miller's results and getting progressively closer to the values predicted by relativity theory. All right, so 1.3 relativity. In the context of the failure of the ether theory, special relativity was introduced by Albert Einstein in 1905. Relativity has numerous experimental confirmations, with one of the most influential being the 1919, when general relativity was confirmed by the observation involving the bending of starlight by an eclipsed sun. Mainstream opinions progressively hardened in favor of relativity in the following decades. Aware that Miller's experiment, and by the way, for those of you that need refuting that believe in all this stuff, see my presentation, How Math Became Reality, Space Audits, episode number 11.
Yep.
And you'll learn all about the importance of this observation to confirm these theories. Because what happened here, what's not being discussed really in this paper, is that this experiment disproved, like, they had two options. They said either there's no ether or there's no Earth movement, and they went with no ether. Because they all assumed that the Copernican principle in Kepler's laws and all that were gospel, and it just worked, right? So the motion of the Earth was an absolute fact, didn't require any sort of experimental evidence. So when they had the technology to do the experimental evidence and it came back null, that's why they were like, what the fuck? What do you mean? We're moving right through this shit. And then they were like, well, there has to be an ether because dude's equations. And then so that when they get into special relativity, what they did was, they applied a transformation equation and introduced reference frames. And they said, well, starting off, actually, before they get into that, Lorentz introduced the idea of the ether compressing the molecular structure of physical objects in the direction of motion. So he said that a possible explanation to the quote null result was that there was ether compression.
Yes.
And that to express that, he came up with something called the Lorentz transformation. And so from that, assuming that the Earth is in motion and assuming an ether, he was able to save both models. Now, Einstein came along in 1905 and said, hey, wait a minute. If we remove the ether and just say that it's a vacuum and that, space and time and physical objects contract in motion, then we can get out of ether altogether and say that it works that way. So what they ended up settling on, without a physical mechanism for contraction, was just saying that from the reference frame of the sun and the Earth following it, that the device would be contracted by the exact amount that would give a null result if it were in the 30 kilometer a second motion. So like they did a complete flip flop to get into another. They basically introduced an entirely new branch of physics by saying that the traditional Cartesian coordinate system XYZT, linked with depth, is expands, contracts, and all that, and it's all relative. And each coordinates and each axis can be relative to one another respectively. And they added a fourth axis for time, and they said, "Oh, that shit's relative. Anything can be explained when we apply a transformation to it to say that." There was a contraction, based on the Michelson-Morley results. So they can just extrapolate it, a story to explain why there's no motion, even though they know that they're moving, even though it's a fact based on their presuppositions. So I think that, Jim, did that kind of cover the introduction into what we just read from the paper about the context into why this was all introduced and these experimental confirmations? Because so they introduced special relativity in 1905 to explain Michelson-Morley, and then 1915 they proposed general relativity to explain everything else because they really had to.
Yeah, your time frame works. 1887 Michelson-Morley, 1892 Lorentz contraction, 1905 special relativity. 1915, November 25, 1915, Einstein published his 16 partial field equations. 1919, May 29th, 1919, 2 expeditions, one led by Eddington. November 6, 1919, Royal Society confirming Einstein, making him the boy, announced to the world November 7th, Einstein's their boy. And then 1922 in Japan at Kyoto, Einstein saying that he did special relativity to help explain away Michelson-Morley in 1887.
Yeah. Yeah. So that's basically the time frame. Thank you for that, Jim. Much appreciated. Yeah, so let's keep going here. So okay. Aware that Miller's experiment contradicted relativity, Shankland co-authored an oft-quoted paper in an oft-quoted paper in 1955 attributing Miller's results to experimental error. And yeah, everyone that I've brought up Miller to, they immediately are like, "Oh, experimental error." They just boom, temperature variation. It doesn't work.
Yeah. and Shankland was the guy hired by Einstein to discredit Miller. And he did.
Yeah, they were boys, man. They were boys. And also, if I remember correctly, Shankland also worked with Miller. So if you were going to have somebody do like an objective analysis of the data, maybe not someone who's friends with Einstein and also friends with Miller and all that kind of shit, right? Like you would have someone who's a neutral party analyze it, but they had, your boy do it. So anyway, Miller's results, which contradicted relativity, have not been replicated in spite of numerous trials. Shankland ascribed Miller's results to experimental error. These circumstances eliminate Miller's experiment as a refutation of relativity theory. Replication examined. This section is a novel examination. This section is a novel examination. Am I retarded? This section is a novel examination. The validity of the. Why does that read so weird? The validity of the claimed replications of Michelson, Morley, and Miller. So this section is a novel examining the validity of the claimed replications. Okay, so section 2. This must be like a typo, and I just brain farted hard on it. Okay. Requirements for replication. The sensing region. In a Michelson-Morley experiment, the input beam is split into two beams which travel perpendicular to each other. Each of the two beams is reflected from mirrors that leave their direction parallel and anti-parallel to their direction after being split. Finally, the perpendicular beams go through the beam splitter again and come out parallel to each other. The two perpendicular paths of the two separate beams constitutes the sensing region. The sensing parameters. The sensing medium is the physical medium. The sensing medium is the physical medium and the sensing region. It is usually air or a vacuum. The sensing length is the length of the path between successive reflections in the separated beams. The path has no intermediate reflections. The number of traversals of the sensing length may also be relevant. A replication of Miller's experiment must either exactly replicate Miller's sensing region or must guarantee to preserve any legitimate effects that Miller recorded. Instrumentation outside of the sensing region is irrelevant. Since we do not know the full mechanism that produced Miller's results, we cannot be certain that any modification to his sensing region will preserve the effects Miller recorded. This is a really good point. That's fantastic. What a fucking homie. All right. Miller's sensing parameters. Miller in 1925-1926 used ambient air in the sensing medium. His sensing length was 2.5 meters. Or it's not even close to what I was reading. Was 4.25 meters. The full sense of the length traversed 14 times and a half length traversed 2 times by each of the separate beams. So what was they talking about? The sensing, the two perpendicular paths separate the beams constitute as the sensing region. The two perpendicular paths separate. We'll have to look at it in the diagram. Miller's sensing parameters. Miller in 1920. Okay, I read that. Replication candidates. Jews in his 1930 Michelson-Morley experiment used a vacuum as a sensing medium, and his sensing length was about 3 meters. This does not replicate Miller's parameters. Herman in 2009 used a vacuum at the sensing medium of with an arm length of 5.5 centimeters. This does not replicate the parameters. All other replication candidates use sensing lengths less than that of Jews, and most used a vacuum sensing medium. Therefore, they do not meet Miller's an analogous replication of Miller's experiments. And this is really important because the counter arguments that we're facing, they're going to say, well, they've done experiments since then. They've done XYZ since. And why is it tending towards 0? Why doesn't it show the same things that Miller said? This is why. Because they're not analogous. If you change it, like dude's saying, we don't know the cause of what produced the results that Miller detected. So making modifications to it and then rerunning it isn't going to tell you shit, you know? It's not going to tell you anything unless you already don't want to believe in it, and don't want to be critical of it. You can then just turn to that and go, well, they didn't get it. It must all be the same. It's really not. It's really not. Okay, replications and conclusions. This paper's almost done here. Replication conclusion. Based off the differences of the parameters using the sensing region between Miller's experiment of 1925 and 1926 and all candidate replications, we must conclude that Miller's experiment has never been replicated, contrary to all claims. And that was from a lad in 2012. I think this paper was written. Miller's experimental results have not been replicated because Miller's experiment has not been replicated. Analysis of Miller's data. So this is where we're going to get into how you can do different statistical analysis, to derive whatever you want. Just you basically start off with a framework, so you cook in your assumptions or whatever, the different things you think you need to account for and adjust for. And from there, you can really do whatever. But I'm not saying that it's not a useful tool. It doesn't have its purpose or anything like that. I'm just saying when you're dealing with this kind of situation and everything is hinging on all this, and if you really wanted to make some data fit whatever you needed, you could do that and push it through, and it's not going to get a lot of pushback. As we could see that's the case because people did just that by doing not analogous experiments and then presenting them as if they are analogous to Miller's original experiments, which by Miller's data would be a direct refutation to relativity theory. So we'll continue on. Jim, did you have anything that you wanted to chime in and talk about?
No, I'm just making notes, so yeah, cool. I'm all good.
Cool. Okay, so analysis of Miller's data. So Shanklin, and this is the guy we were talking about earlier that was hired to review Miller's data. He was a close friend of Einstein. Well, we'll get into it. He talks about it in the paper. So anyway, analysis of Miller's data, Shanklin's analysis. Shanklin and others published a paper in 1955 that ascribed Miller's experimental results to statistical fluctuations in local temperature conditions. So basically saying experimental air, temperature, gradient fluctuation, yada yada. He didn't measure anything. What they're saying basically is that the temperature of the ambient temperature of the atmosphere, expanded the device slightly, and then when it cooled, it contracted it slightly, and that's what caused the interference patterns. Cook your assumptions. And I had some meth, and what up, Jeremy R? Welcome to the stream, sir. Hope you're enjoying. We're covering an analysis of Dayton Miller and subsequent experiments that were done following Dayton Miller that were not analogous to his experiment, and we're just kind of going from there. So anyway, Shanklin and others wrote a paper in 1955 that ascribed Miller's experiment to temperature fluctuation errors. Shanklin became a chairman at the case physics department following that, and Miller received the following department following Miller and received the 1925 and 1926 experiments records directly from Miller. Shanklin was a friend of Einstein and is considered biased by many, including Demus, don't know who this is, who presented an in-depth account of both Dayton Miller's work and Shanklin's critique. Ooh, But we will definitely be looking at what this guy had to say. Let me write that down real quick. New analyzes Miller and Shanklin's critiques. Yeah, dog, we will be following up on that. All right. So we got, and then, okay, so that was Shanklin. So Shanklin chalks it all up to temperature fluctuation. And this is Maurice Elias's analysis. Maurice Elias published a paper in 2003 strongly supporting Miller and refuting relativity. Elias used a general mathematical method and found... Dude, that's so funny. This was in 2003. Anyway. Striking... Elias used a general mathematical method and found striking regularities in Miller's data, including, but beyond what Miller found. Wait. Data, not only that, but beyond what Miller found. Okay, so there's typos in here. Elias declared that relativity was totally invalidated by that observational fact. Elias wrote, in fact, as far as the temperature effects are concerned, Shanklin and others only present hypothesis and doubtful reasoning. They themselves emphasize that the available temperature data is quite insufficient to perform a precise analysis. Fucking fantastic, dude. How about that, Jim? They discredit the man's work, and they don't even have enough fucking temperature data to fucking discredit it, bro.
Yeah, it's a hit job, big time. Absolute hit job.
Dude, you know it's bad when they're like, yeah, I mean, we don't even have the data, but fuck it, right? These people are wild, bro. You gotta really watch them, dude, and you have to read their fucking papers, because when you have a conversation with someone about that, they're not necessarily lying to you, especially if they've done the work on their side and read the things that support their arguments. You know, they're just gonna be like, oh yeah, it surface level narrative, obviously. They're gonna be like, oh yeah, temperature fluctuation dismisses it all. Not even close, apparently. And we're gonna get to what this guy had to say about it, because we're gonna find out as much as we can about this data and the information about it, because it's such a direct refutation to relativity theory that it's crazy. There's really no going back for them should this be the case. So we're definitely going to look at all avenues of it, and then form a conclusion. We're going to be very scientific about this, Jim. What do you think?
Well, I think we already know what the answer is, but we're gonna go over it, and we're gonna see all the details.
I mean, if I was gonna quote Arthur Eddington, I'd say, admittedly, I am biased in my planar belief, but I'm just gonna go ahead and make the data fit my hypothesis anyway.
Well, Eddington was the whole thing about Eddington was with his May 29th observations, and then the Royal Society November 6th. He was going to release a very positive claim on the bending warping of space-time. I mean that was the whole purpose, was to do that, and to say of the 32 slides they took on May 29th, 2 of them were going to prove, the bending warping of space-time. And if you look at those 2 slides, they don't prove anything, but they went with it anyway because Newton was going bye-bye, so they had to replace Newton. They replaced Newton with bending warping in space-time, which nobody can prove. But hey,
can't prove it at all, bro. Can't prove it at all. Oh, but Alan-Michelson, didn't you just read from the beginning of the paper where Eddington proved it? Nah. I mean, I did read that, but he didn't prove it. So anyway.
Yeah, everything was cooked in the books. And when they went in November 6, 1919, they knew they were going to end the day with with the USA and the UK press having Einstein as their boy. It was all predetermined.
Certainly seems that way, Jim. And they certainly know how to roll out a press narrative. You know, like this isn't something that they just learned about, right? Like you can find instances of what is it? This happened in what was that? Oh shit. I can't think of what I was gonna say. Didn't oh, it had to do with the Rothschilds and how they undercut or like what do they bet against the city of London or whatever, and they announced that that war was won or lost beforehand, and then everyone thought that London or whatever was going to go bankrupt, so they shorted everything or something, and then they ended up buying everything. I forget the whole thing, but basically, you know, when you have control over a narrative and you present it to people, people are going to react to it and run with it, you know, like because they don't have the full scope of the rest of the information. So if you do that to people, you know, you can control it in that regard. So like they've known about this method of delivering information to people and getting things hyped up and getting people all on board with stuff that that you know that they don't really know nothing about, but they just get real passionate about it. So
it's a behavior psychologist, you know, wet dream. That's what it is.
Yeah, it really is. And yeah, so we'll continue on. We're almost done with this paper here. So they themselves said that that Shanklin and others didn't even have enough data. So Elias, who was French, who is nearly unknown in the Anglophone of the world, as he was reluctant to publish in English, although he was awarded the Nobel Prize in Economics in 1988. He had an early interest in physics as an experimentalist in gravitation, and he established the Elias effects. Yeah, he was also a physicist too, not just a Nobel Prize winning economicist. What's the what word am I looking for? Economist? That's the word.
Yeah, economist.
Economist. That's definitely a word, Jim. Right? Go ahead. It's a word.
In a world of relativity, you can say anything you want to.
Absolutely. Thank you. Elias.
Because the world is not an absolute.
Hell yeah.
Here you go.
Elias was awarded the French Legion of Honor and was elected to the U.S. National Academy of Sciences and corresponding academies in France, Italy, and Russia. So yeah, your boy Elias knew what was up. He knew, you know, he knew how to manipulate the maths and how to do it, how to figure things out. And his analysis was that Miller was spot on. And when you get into his work, which I can put some links in the chat, or I'll put them in the description later. Actually, I'm not going to dig them up now and detract, but you can look at the stuff that he goes over, and he talks about, like, he has some what do you call it, like slides, like some little graphs and shit to show you what he's looking at and like how it correlates to everything. I mean, he goes over it and he's like, this is where it starts and this is where it stops, and it's all in relation to the equinoxes, and he points out all of this from his own analysis of it. So anyway, so that's Maurice Elias's thoughts on it, and this is wrapping up the paper. A crucial experiment. Replication of Miller needed. We have seen above that 1. Dayton Miller's experiment, taken at face value, refuted relativity theory. Maurice Elias's mathematical analysis of Dayton Miller in 2003 concluded that his data refutes relativity theory. Miller's experiment has never been replicated. Many very accurate Michelson-Morley experiments have been performed, but all with the wrong parameters. Einstein said, if Dayton Miller's results should be confirmed, then the special relativity and the general theory of relativity in its present form falls. Rest in pieces. Miller's experiment has never even been properly addressed. A properly controlled replication of Dayton Miller's experiment, 1925 to 1926, must finally be performed. Such an experiment will either show Miller's experiment was in air and relativity remains unchallenged, which it's not, I challenge it. And Miller's experiment is vindicated and the relativity falls. So excellent synopsis there. Really good. Where we've been and where we're at now. Replication of Miller. The proper replication of Miller's experiment is a Michelson-Morley experiment that must include the sensing parameters given above. So it needs to be in a vacuum, and it needs to be, was it at the intersection point where the lines or where the beams realign? I can't remember, but there are specific parameters that must be met in order for it to be analogous to Miller's experiments. And the reason for that is we don't know what caused the results, or what caused the fringe shift patterns. So doing different experiments that aren't analogous to it with different parameters, different arm lengths, different mediums, different sensing parameters is just, it's obfuscation at best, right? I mean, Jim, these are science people, right? Like science people. These are people that are like, that have that scientific inclination, right? That are like, this should be obvious, right? Like if you're gonna do an experiment, it should be to invalidate or validate it. It should be analogous to the one that was done, right?
It's the I don't have the quote right here. I can find it easy enough. It's that gentleman Humboldt, Humboldt, a long time ago. It's an old quote, who said that he was not going to be the first person to question Copernican theory. What Copernicus came up with. He wasn't going to be the first person to do it. He questioned it, but he wasn't going to be the first person to actually go out and publish that Copernicus was, his theory was all wrong. And so today, and back in these days, 25, 26, 27, along with what Shanklin did, nobody was going to question their boy Einstein, and they weren't going to be the first person to do it either. So when Humboldt didn't do it with Copernicus, let's fast forward 450, 500 years, they aren't going to do it with relativity and Einstein. It's the same thing.
Yeah, absolutely, man. It's a real shame because, not doing it, not facing Miller's data head on and doing these experiments analogously and doing that is just, it's a telltale sign that they don't want to know.
Well,
because they could have, but they've just done ones that aren't analogous and then gone, well, didn't match, so we're good to go.
They want to keep their paychecks coming.
Yeah.
Here's the quote. I knew I could find it. It's by Alexander von Humboldt, Humboldt. I have already, and this is his supposed quote, I have already known a long time that we do not yet have proof for the system of Copernicus, but I shall not take the risk to be the first one attacking it. So that was Copernicus, and nobody will go after Einstein's relativity because they know it's kind of bunk, but they don't want to be the person that attacks it first.
Yeah.
Same thing. So it doesn't matter if it was 1550 or 1600. Doesn't matter if it's 1925 or 1950 or 2023.
Dude,
Nobody will have to go after it.
I mean, look at the way they talk about the experiments, even now knowing, like, so this dude went through all that research, and obviously, I'm gonna guess that he read, so he read the luminous, the motion of the Earth, or the omni relative motion in the luminous effortless ether. So he knows that it was a test of two paradigms, ether and Earth motion. And he does it in this guy's paper. He's like, it was just an ether test. Like, there's such a bias formed around it from the framing of how it's taught to everyone. You know what I mean? That's like, you're intrinsically not critical of it, really, because it's just fundamentally true. They're like, oh yeah, well, and despite the fact that you could find tons of quotes where they're like, it either meant the Earth wasn't moving, or it was at rest, and that there was no ether, everyone's just like, yeah, it was an ether theory test. It failed the ether, which think about how crazy this is, Jim. it failed the ether test, which somehow proved that the Earth is in motion.
It,
It's like,
it,
what?
Yeah, it's what I read to you before we went on, before we went on the podcast. I read a couple physicists quotes. One is the data of Michelson Morley was almost unbelievable. There was only one other possible conclusion to draw, that the Earth was at rest. Physicist Bernard Chaffee, Jaffa, out of Michelson and the Speed of Light, 1960, page 6. And then you had the quote, and I won't read the whole quote, but it's from a physicist, Richard Wolfson, and he says that they didn't detect the 20 miles, per second around the Earth as what was expected. They didn't detect it. So what was the conclusion from Michelson Morley? The implication is that the Earth is not moving. Physicist Richard Wolfson, and I could read you a lot more than this, which you probably are aware of as well. But you see that what came out of Michelson Morley was not necessarily the ether. It was the fact that they didn't see motion of the Earth around the sun, 30 kilometers per second or 18.6 miles per second. They didn't find it. They found 3, 5, 6, 8 kilometers per second, and they had to explain it away. And Shanklin was hired by Einstein to discredit Miller. And Einstein even said in 1922 in Japan at Kyoto that he wrote special relativity in 1905 to explain away Michelson-Morley 1887. So in 1922, Einstein was still thinking about 1887, 35 years before.
Yeah, he was still having dreams about it, bro.
Yeah, and every once in a while, this because I would never lie to you, that every once in a while I see Einstein in the corner of my apartment, and he talks to me about it. And then I was at the library, about 6 weeks ago, and Einstein showed up there twice while I was giving my little presentation about the Schwarzschild metric that was going to the James Child metric. And Einstein talked to me twice then. So, Einstein, I call him Ein, for
Right.
short. Ein and I are buds. We're tight.
Totally. Okay, so Jeremy says, what would replace general relativity, and can you describe what the ether is? I've only heard about it within the past couple of months. Yeah, so in terms of what the ether is and all that, no one really knows what it is. We don't have a mechanism for anything for it really, but the ether model was modeled after the classical mechanics. Classical wave mechanics. So, and how that was modeled was basically after acoustics. So they took a sound wave, they took the model of their understanding of that, and they went, okay, so the wave has to propagate through something, and then what is it propagating through? It's propagating through air. So the medium of air facilitates the propagation of the wave, so that it can, do its thing, right? So that it can produce an auditory noise that we hear. Like, so what's happening is, there's a frequency that's being emitted from something, and that's causing an excitation in the background medium of air, which is causing the molecules to vibrate or oscillate, right? So it's an oscillation. They start spinning, right? That produces a frequency. That produces the what's the word I'm looking for? That produces what you're hearing. Can't think of the word. And the wave propagating through that medium, and the medium itself vibrating, the molecules vibrating, is what is producing you hearing that sound, right? So they took that model and they were like, okay, so electromagnetic phenomenon must also work that way, right? So there must be a medium to work through. So what they supposed for magnetism, for electromagnetic energy, light and all that shit, they said that there must be some sort of a background medium similar to, how air facilitates the propagation of sound waves. So they just called it the ether. And what that did is it provided the mechanism for all that. So if you'll notice how everything has a tendency towards entropy too, right? So hot to cold, high frequency to low frequency, that sort of shit, right? So everything has a,
high pressure, low pressure.
High pressure, low pressure. Everything tends to seek equilibrium, right? To seek its state of rest. So the ether, not being affected by anything, is in a state of rest. And then when it gets excited by frequency, so like, for example, you're in a dark room and you turn an LED light on. Well, the LED light or the electricity and shit in the LED starts producing a frequency which causes an excitation in the background medium, and that produces the visual illumination that you see, the visual light spectrum. So that's what that. And when you turn the light off, what happens? Or when you stop emitting the frequency from the LED light, what happens? The light, it stops illuminating. The excitation stops, right? The vibration of the background stops. So this there's different postulates. There's different hypothesize on how the ether works. What the mechanism for it is. Is it a super dense medium but with like no viscosity, or is it does it have viscosity, or is it just super thin, like blah blah blah. So that kind of shit, right? So in terms of how this all is in conjunction with relativity theory, is that they did an experiment in 1887 to test the motion of the Earth and to test their current understanding of the stationary ether. And what they found was that there was either the results of this test yielded an 8 kilometer per second, or I'm sorry, yielded a fringe shift pattern that is in accordance with a velocity of 8 kilometers a second. Now, their predicted velocity was 30 kilometers a second, and they need that to meet the heliocentric model requirements for the rotation of the Earth around the sun to complete a full year and all that, to explain everything. Has to meet the 30 kilometers a second, and they only got 8 kilometers per second. So they came up with special relativity, and they introduced the idea of inertial reference frames, and they said that basically what relativity says is that from the reference frame of the sun, the Earth, the Earth being in motion towards it, the device, the Michelson-Morley device trying to measure the motion was contracted in the direction of the motion, which produced the exact amount required to produce an 8 kilometers per second shift, even though it's really traveling at 30 kilometers per second. And they literally just reverse engineered the result to match that.
That's exactly what they did. That was Lorentz contraction, and they only did it with the motion of the Earth and direction of the motion of the Earth, and not perpendicular to the Earth, because the perpendicular to the Earth, basically, matched what the motion of the Earth was going in one direction, and the perpendicular going the other way. It screwed it all up. So they kept the perpendicular where it was, and they shortened the light, or they contracted the light, so they reverse engineered that it would come out to 30 kilometers per second away from what they actually saw. So everything was done. I think Michelson-Morley was on the up and up, but Lorentz was basically in bed with Einstein, even though they might have disagreed on a few things. And so Lorentz actually saved Einstein's rear end when it came to relativity with Lorentz contraction. And then you also get the Lorentz transformation, or transform, which actually saved the coordinate system of 1 to the square root of 1 minus v squared divided by c squared, which is one of the transformation equations. And so Lorentz saved Einstein there too. Einstein did actually nothing. Einstein was the boy that was in front of the camera that usually talked from notes, that stole Barrera's Mercury precession, the perilinum precession of Mercury. He stole that from Verrier, Berrier. He stole the photoelectric effect. He stole E equal mc squared, and he stole relativity.
Oh,
So
hey. Sorry.
Einstein was the boy that stole everything, and he was definitely a front man. And his life outside of whatever he did, he was a pervert. So I'm sorry that upsets people, but that's how it was. If you look at 1887, now we know Dayton Miller 1925 to 26. I went as far as 1922 to Kyoto. You can actually go to Dayton Miller 1925-26 now, and so if you go from 1887 to 1926, that timeline tells you what the world has been living in for the last 100 years.
Yeah, absolutely. Well said, Jim. Thank you for the synopsis. Yeah, Jeremy, it's it basically is just how they assumed it would have to propagate, and they came up with math equations to express that. And the original Maxwell equation included a what is it, an ether, but then they removed it. So yeah.
Could I respond to Jeremy for a second?
Oh yeah, absolutely. Oh yeah, let me say hi, hey to Cammy. Hey, welcome Cammy and welcome JT. And yeah, that's I was telling you about that earlier, Jim. Cammy.
Yeah,
So
I just wanted to, what would the world look like without relativity? I think what Jeremy was kind of hinting at.
hmm,
In a world without relativity, you have light that is spontaneous. You have a world that is, of course, there's no universe, it's just us. And you definitely have the Gaussian, the two Gaussian surfaces. The top one may very definitely be a sphere, or a dome, or whatever you might think it is. Of course, the bottom Gaussian surface is a stationary flat plane, and you have the sidereal rotation of the sky, which can give us downward motion to the Earth, which gives us some Coriolis effect, maybe in the southern latitudes, and you get something that's truly wonderful. And you're not lying to people. You're not lying to children.
yeah.
And you're not lying to children. You're not spending $50 billion to not go into outer space through Space Force and NASA, and then all the other 75 space agencies. And guess what? Military budgets, which are $2 trillion last year, might be cut by two. We have a nice world, and we don't lie to our children. That's what it would be like if we decided to give up on relativity.
Hmm. Yeah, I'm not sure if I agree necessarily with how everything would turn out, like,
Well,
much better or whatever. Like, it would be like a utopia paradise or something. But
well, no, no,
like, I'm sure they would definitely come up with another mechanism for the deception. But yeah,
the other part, the last part of that was just wishful thinking.
yeah. Yeah. So we'll go ahead and close on. Jesus, there's one more page. All right, we'll bang this out and then we'll continue on to the Redshift. Oh, is it?
He lived 1879 to 1955.
Yeah. All right. Let me
And
read.
then he also lives in our dreams and in corners of people's apartments.
When I
and
look out
houses.
at the stars, sometimes I see him twinkling. Like, I see a little eye. Like, there's like a little star that has like fuzzy, fucked up hair. And I'm like, is that you, Ein? I see you, buddy. That's him.
In the upper left hand corner is his first cousin, and the upper right hand corner is the first cousin's underage daughter.
Yeah, I don't really like to look at that one.
Uh-oh.
But let me read this out real quick, and then we'll proceed on. So, beyond replication, however, the experiment can be more than a replication of Miller. Since the density of the sensing medium is suspected of affecting the results, I suggest making the gas pressure an experimental variable. In this way, it should be possible to replicate Miller's non-null result at atmospheric pressure and to replicate Jou's null result at vacuum by running the same apparatus at these two pressures. Intermediate results should be interesting as well. Assuming the above experiment gives results agreeing with Miller's and Jou's, data can be taken at the pressure intermediate between near zero and 1 atmospheres and above 1 atmosphere. These data points should fall on a monotonic curve. This would be far more credible than the two isolated data points, and even more interesting would be to run two synchronized isolated experiments at perhaps 100 feet apart from each other. Correlated noise in the data from the two experiments would be a strong evidence for disturbances in the ether pervading both experiments. Yeah, so Cammy pointed out that the top Gaussian plate could not be spherical, and that would cause the concavity in the water. So yeah, what some of us think now, Jim, like with the new information that we got, is that the sky might be flat, like what's going on above us, but then like there's a dome or something. It gets very very weird up there where it's hard to verify everything. But yeah, but in the Gaussian surface, if the bottom one's flat, then the top one would also have to be flat. It hands down has to be. Otherwise, it doesn't work. So So slightly inaccurate description of the Gaussian surface per se, but
I think
but that doesn't mean that there can't be like a curved firmament like above that or something, you know,
yeah,
or however it works. But
exactly, because there has been a discussion in the last 4 to 6 weeks that some people have put forward. I'm not going to name names, but the Gaussian surfaces are flat on the Earth and then flat above. But then there might be something above that, you know, some people might call the firmament, and so and that may be where the stars may be at. So there is a discussion that the Gaussian surfaces are flat, bottom and top, and then there is something above that. Now, we don't know. It's just a discussion,
yeah,
and it's an
yeah, just
interesting
yeah,
discussion.
just working through ideas, just trying to maintain consistency in the vernacular. Because
Exactly.
I'd hate for you to start talking about that with someone, and then you're like
No,
curved top Gaussian, and they're like, well, it can't be curved, and
no,
then they just kind of
no.
so
It's the same thing. I shouldn't do it. Just like we shouldn't talk about extra lands outside of Antarctica.
well,
You
no,
know
it's
what?
it's okay, like what we were talking about, but you just kind of were a little
Oh yeah, I
inaccurate
did.
on it. No biggie.
I did.
No biggie. Let's see. So we'll save that for later. Let's see. What were we gonna read? We were gonna read. So John Earlman and Clark Gilmore, the gravitational redshift as a test of general relativity, a history and analysis. So to catch everyone up, a little lesser known story about the Arthur Eddington observation is that the whole time that was going on, there were spectra readings going on. Yep. Um, while the Eddington observation was going on for the displacement of starlight, the bending, they were also doing spectra shift observations by these two guys, Charles St. John's and John Evershade, who were the world's premier spectroheliograph, photographers or whatever in astrophysics. And these two guys were, analyzing starlight, Anus, and they never found any gravitational redshift, and that's a direct refutation to relativity theory as well, because even if, as it travels along that curvature, there must be an energy exchange facilitated between the. Oh yeah, so Cami, I wanted to ask you about this. In order
I
to
don't know if you
produce,
can hear me, but
so lame.
yeah, we were doing real good there for about an hour. Yeah.
All right, I'm green now. I should be good to connect. All discussions great. We need to throw out all ideas and test with reality. Absolutely. Cami, what are your thoughts on this? I was looking into this gravitational redshift situation, and what I found was, you know how they model everything off the Doppler effect. Yeah. It should be okay now.
Yeah, he is cut.
Is it
Alan
still
is cutting in and out once in a while.
is it still cutting out, Jim, or is it back to solid? That's unfortunate, man.
Yeah, we were doing good for a little over an hour.
Yeah. I'm not sure. I'm going to give it a second here. It's green again, so.
I was going to respond to is it Ashling 717? Is that Ashling?
Aisling?
Aisling. I think it's really great to have a. You were kind of saying, I think it's great to have a back and forth, away from what we've been taught. That we live on a spinning space ball in the vacuum of outer space. That we can actually throw out ideas that are different than the status quo mainstream narrative. I think it's a great thing to be able to say, hey, maybe this happens, maybe this doesn't happen. We say it, maybe it doesn't sound right. I think it's great to have a back and forth away from what we've been taught.
Yeah. Okay. Yeah, thank you, Jim. Absolutely, and I agree. Am I good? Can you hear me solid?
I can hear you good now. Uh-huh.
All right, cool. Hopefully this works. Okay. Yeah, so for the Doppler or for the gravitational redshift that they would say that applies to starlight displacement, for example, how it travels along the curvature of space-time, would you not need to facilitate an energy transfer to produce the redshift? In other words, the photon just isn't going to magically start expressing redshift unless it's interacting with something, right? So like the curvature of space-time would in fact have to be physical in some regard to facilitate that redshift, right? Like, does that kind of make sense? Because that was started lagging again. Super upsetting. I have really good internet too. God, it's pathetic, man. Okay, well, full green bars again. But I'm afraid if I talk, it's just gonna. Yep, it's red again. Nice. I guess I'm a fucking idiot. Yeah, if it doesn't sort itself out here in like 2 or 3 minutes, I'm just gonna call it for the night, and we'll figure it out tomorrow. I don't know why it's being super weird, man. No one's even using the internet right now, and like I stream all the time on Twitch, and it's like for hours, 6, 7 hours at a time. Works fine. I'm watching the little green bar. Okay.
Yeah, this time of night on a Tuesday night, Wednesday morning, you wouldn't think many people would be online.
Yeah, I mean, no one on my house is even using it. Later, bro. One day we'll have a complete show. That doesn't disconnect. I found out why we disconnected on our first one too. I was using Restream, and they have a 3-hour limit, so it just hard DC. That was our most successful stream. That was a solid 3 hours, no interruption.
Yeah, maybe you're upsetting the YouTube overlords. Who knows?
Yeah, I mean, I don't know. It seems to be okay now, so I'm gonna continue for a minute, and when
Sure,
if it
I'll let you
DCs,
know.
yeah, if it DCs, just cut me off and tell me, because I hate talking like a fucking robot. Okay, so these two dudes were supposed to establish a cause and effect relationship with the redshift observed in 1919 during Arthur Eddington's eclipse observations, and prior to the eclipse, they were actually doing observations with other stars and the Venus transits, and they never found any displacement. I'm sorry, they never found any redshift at all in agreement with relativity theory. And actually, I don't even think they found any redshift. It's very hard to say now that I'm thinking about it, because it's worded weird and there's no available data to see. So you get kind of different stories on it. But from my understanding, they either didn't see any, or whatever they did see didn't match relativistic predictions. But I'm going to go with they didn't see any, because that's how I've read it directly from Dr. Silverstein or whatever at the Royal Society meeting. So we'll just go with what they were talking about there, and we'll go from there. And so anyway, this dude, these John Earlman and Clark Gilmore do like a recount of this untold story, so to speak, and they compile a bunch of people's thoughts on the matter as it unfolded, and we're going to kind of go over the historical narrative that is a lesser known talked about aspect of relativity theory, as no gravitational redshift observation being observed would be a direct refutation to the theory. Even if there was starlight displacement, and even if you can explain the perihelion precession without the redshift, none of those two observations are enough to give physicality to space-time curvature to say that space-time curvature is what caused the redshift, right? Because in order for that to happen, the photon, so-called, has to be traveling along the curvature of that space-time so that it can have an energy exchange with it, so that it can have the redshift, so that my boy St. John can be on Earth and observe it. All right.
That's so stupid.
So sorry to have multiple delays on getting through this, but I started lagging out there. So anyway.
Oh, I have another one from your PDF, from your 94-page PDF, where you have that one page where Einstein said if these things can be, shown not to exist,
Yeah.
then, those three things,
Yep.
parallelism, precession, and then the two gravitational, that would be a great podcast to have too.
Yeah. I mean, that's all in the presentation too. But yeah, we'll definitely cover some of that stuff later and do like a recap on it. So yeah, we'll read through some of this. 40 pages here.
You've been good for the last 5 minutes as far as your voice.
All right, cool. Well, since it all worked out. All right, so before we read this, let me just ask Cami now, since it's actually working. Cami, am I correct about how I'm interpreting this energy exchange with the so-called medium of space-time so that it can produce the redshift effect? Is that would that be an accurate understanding of what needs to happen in order for us to even see a redshift from their paradigm? Obviously, there's there's more causes of redshift, but specifically in the way that they describe it, it would have to be due to the curvature of space-time in a physical sense, not just a mathematical description of the coordinate system, right? All right. Wait for the reply. Okay, so Charles St. John, who was in 1921 the most widely I don't know because it totally cut out on me while you were discussing. No, it happened again.
It did for a few seconds.
It's actually kind of crazy. Every time I bring it up, it just immediately start lagging out. It's really fucking weird. Brandolin, looks like you're using OBS. Might be from the system processor overload or something. I've seen OBS freezing OBS stream. Try closing. Yeah, I have a really good computer. Everything that's unnecessary isn't running. And there's really no reason it should be doing it. Like, I've got really good settings on all that stuff, and I've streamed on other platforms, 6-9 hours at a time, never had any issues. So I think it's just my internet's just taking a shit tonight. So anyway, so this dude was the most widely respected student of the Fraunhofer lines in the solar spectra field of study. So when we're talking about observing spectra lines in involving the sun, this is your guy in 1921. Began his contribution to a symposium in Nature on Einstein's theory of relativity with the following statement: the agreement of the observed advance of Mercury's perihelion and the eclipse results from British expeditions in 1919 with the deduction from Einstein's law of gravitation gives an increased importance to the observations on the displacement of the absorption lines in the solar spectrum relative to terrestrial sources, as the evidence on this deduction from the Einstein theory is at present contradictory. Particular interest, moreover, attaches to such observations in so much as the mathematical physicists are not in agreement as to the validity of the deduction, and the solar observations may eventually furnish the criterion. So what happened here was they were trying to establish the cause and effect relationship with the perihelion precession, which Einstein's theory was, able to predict, post-dict, and then the displacement that Arthur Eddington allegedly observed. So this was going to be the cause and effect relationship. So again, similarly to how the Doppler effect has a energy transfer exchange with the medium of air and water molecules, the photons, the starlight, or the photons coming from the stars or whatever, was supposed to exhibit a similar energy exchange with space-time curvature, and that was supposed to cause the spectral shift, and these guys didn't observe any. So we're going to continue on with this narrative. Cool, lots of chatting going on. All right. St. John's statement touches on some of the reasons why the history of the redshift provides such a fascinating case study for those interested in the scientific reception of Einstein's general theory of relativity. In contrast, the other two classical tests, the weight of the early observations was not in favor of Einstein's redshift formula, and the retraction of the scientific community to the threat of disconfirmation reveals much more about the contemporary scientific views of Einstein's theory. The last sentence of St. John's statements points to another factor that both complicates and heightens the interest of the situation. In contrast to Einstein's deduction of the advance of Mercury's perihelion and the bending of light, considerable doubt exists to whether or not the general theory did entail a redshift for the solar spectrum. Even the ablest expositors of the theory seemed unable to give a clear and cogent derivation of the Einstein effect. Indeed, our search of the literature has not turned up a single unproblematic presentation of the correct formula for the redshift prior to the mid-1920s. So indeed, our search of the literature has not turned up a single unproblematic presentation of the correct formula for the redshift prior to the mid-1920s. So they didn't even have the right formula to extrapolate what frequency they would be observing the shift in. That's crazy, dog. They were just out there winging it. Many competent physicists naturally found grounds for objecting to the purported derivations, and less competent ones found an invitation to raise muddled arguments against the theory. The discussion that followed is not always illuminate the theory, but does not always illuminate the theory's goals. Whatever. But it is exactly the heuristic fruitfulness of this principle of equivalence that tends to obscure what the final theory says about redshift. Many attempts have been made to remove the looseness and the vagueness of the general theory of relativity to find some premise counterpart within the completed theory. But there is still much disagreement on the matter, and in most of all the attempts, the precision is purchased at the price of the original heuristic power. Here, as in many other cases, a certain amount of imprecision and vagueness seems indispensable. Our task, however, is not that of assessing the validity of the principle of equivalence in light of subsequent developments, but rather that of describing how Einstein used it and how the use affects attitudes towards redshift. The fifth and final part of Einstein's 1907 essay on the principle of relativity and its consequences gave itself over to speculation about the question, which forces itself on the mind of anyone who has followed the previous applications of the principle of relativity. Namely, it is conceivable that the principle of relativity also holds for systems which are accelerated with respect to one another. Einstein argued that the positive answer, at least for the case of uniform acceleration, as we know, the laws of physics are the same for the two systems. Was that a Christoph? No, I don't know what that is. Whatever, sub 1 and then sub 2, where sub 1 is the accelerated direction of its x-axis and the acceleration of the y, while whatever that is, sub 2 is at rest but situated in a homogeneous gravitational field characterized by gravitational acceleration of y along its negative axis. I need to figure out what that is so I can pronounce it. 1 second. What is that weird fucked up E? Sigma. All right. All right. So sigma sub 1, sigma sub 2, gravitational field. This assumption extends the principle of relativity to the case of uniformly accelerated translational motion. The heuristic value of the assumption lies herein that it makes it possible that the replacement of a homogeneous gravitational field by uniformly accelerated reference frames in the latter. Oh, okay, yeah. So they were just talking about how uniform acceleration is the same as being in the center of a gravitational field, basically. Catch up on what the chat's talking about here. That song, good stuff. YouTube. Redshift was only chosen because it supported the expanding universe theory. There are many other choices. In my opinion, Doppler was the wrong choice. Yeah, absolutely. I agree. Because Doppler only really has one way to produce the effect, and that's having an energy exchange with the medium that it's propagating in. Otherwise, the waves can't stack or be further apart, causing a discrepancy in the excitation of the medium, which produces the high pitch. And then when an object passes you, the low pitch, and in that respect. So yeah, I totally agree. They just saw it, and then they were like, "Hey, we'll just go ahead and apply this." But the gravitational redshift that they're talking about in relativity theory is different from that of the cosmological redshift, which is what Hubble presented and equated to Doppler shift. This is slightly different, but still requires a mechanism to facilitate an energy exchange, because otherwise, why would it do anything, right? If it's traveling along a curvature of something that doesn't exist, like in their paradigm, right? I'm just kind of trying to analyze this through how they say it. If it's traveling along curvature of nothing, it can't facilitate an energy exchange. It can't produce any redshift, right? Because the photon, like, it would be interacting with itself for no reason. So it would have to either interact with the gravitational field, which there's been experiments done, namely Pound Repka, Pound Snyder, and a couple other ones, but they all give no results, and they're unable to distinguish between gravitational redshift, which is this hypothetical redshift due to traveling through the curvature of space-time, so to speak. Well, not even so to speak, exactly. And then also, and then they compare that to relative motion, which is just Doppler shift facilitated by the energy exchange of the medium, which I find really really interesting that they just proposed that the light just does it like they don't really talk about the energy transfer mechanism. They just say that it's due. They just imply it by saying that it's due to the curvature of space-time, that it's due to traveling along the curvature of space-time through the gravitational field, yada yada. That's just kind of how they talk. I don't want to keep repeating myself, but yeah, even from their paradigm, it would require an energy transfer, because the bending and stretching of nothing never produced a redshift. And that's why I like that Ken Wheeler video I sent you so much, because when you put the magnet down and then you put the ferrocell over it, when you move the magnet, you're not polarizing the light anymore. You're not causing that energy exchange, and it's not retarding the frequency, which means it's not retarding the wavelength. But then when you put when you put it back under the magnet, all of a sudden, the wavelengths are being retarded, or the frequency is being retarded, so the wavelengths are shortened, and you get that polarization effect. That's what I think is producing it. And it's such a good demo. I love it.
If you take the Doppler effect, and the Doppler effect moves along in the medium, and Einstein removed the medium so he could save relativity, the medium of ether. He removed it and he replaced it with empty space. Then Doppler cannot move as a wave in empty space. It's an impossibility. And so Doppler on a cosmological level out in the universe could not work. Now Doppler can work down here on Earth with with the police car moving towards you, moving away from you with sound. But as far as Doppler working with light on a cosmological level when it's empty space is nonsense.
Yeah, it's really interesting when you apply the internet. They can't. There's no way to. And when you have a magnet, when you have an electric field, you can demonstrate that effect. But when you have a ferrocell over nothing, nothing doesn't cause it, right?
Yeah.
And the experiments that supposedly prove gravitational redshift all give no results and or are unable to distinguish between gravitational redshift effects and regular Doppler shift. So it's fascinating.
Yeah. The idea that something can move along in empty space, no matter what you think it is, but something can actually move in empty space is just, I mean, people would rather believe a big lie than a little lie. If you tell the big lie often enough, sooner or later people will come to believe it. That is such a big lie. People have come to believe it.
Well, that's why let me pull up my presentation on the photon real quick.
Yeah.
Because
very good.
That's why they had to say that that's why they have to say that it's a dual wave particle duality, because the photon can't even travel through nothing. Right. And then they express that through a wave equation where they're just extrapolating the physicality of the photon by multiplying the wavelength times the wave vector, and then they use a reduced Planck's constant that reduces back to 0 to describe the mass. I forget what K equals in this. K is the wave vector. H was the Planck's constant. Oh, sorry. They times the Planck's constant times the wavelength, and then they say that the wavelength's vector times the reducing Planck's constant. So it's like Planck's constant divided by pi or some shit. So it just reduces to 0. So that's how they get it. That's how they say that the photon, it has no mass or whatever, but it's still able to propagate as if it has mass. They just invented an entirely new equation to describe momentum, because if you don't have momentum, which is mass, then you can't have any velocity, right? So I'm sorry, momentum. It's mass times velocity. So if you don't have any mass, then you're timesing your velocity by zero. So you're not going to get any momentum out of that. So they invented a new equation explicitly to describe that. You can cause redshift magnetically under absolutely. That's I cover that in my thing. I don't know if you probably didn't watch the whole video or like anything from it, but I'll show you that exactly real quick, because I found this super interesting when I found it. So Ken Wheeler at 6 minutes, 18 seconds.
Light, which is a coaxial circuit, transverse electrical magnetic, longitudinal dielectric. Let's show you phase shift. Now look closely and I'll explain it. You see how this is blue now? As it was approaching, it went to blue shift.
So what I think is happening here is, and you can kind of give me your thoughts on this too, Cammy. Unlearning is much harder. Absolutely, dude. It's so hard. I'll catch myself doing that stuff still. I'll be like, oh, well, it actually doesn't even work that way. So in this example, right, the LED ring light is it's not producing photons, that are traveling through this magnetic field and stuff that are bouncing and all that and bouncing off of each other and whatnot. What's happening is this LED ring light is producing a frequency, and that frequency is causing an excitation in the background medium, the ether, which is producing this visual light spectrum that we're seeing. And when this ferrocell in the ring light is put over the magnetic field is retarding the frequency that's being put out by the LED ring light. And what that's causing is the vibration. So the ether that's producing the illumination is rotating slower or faster, depending on if it's going with or against the magnetic field, and that's producing the polarization that's causing the red shift on one side and blue shift on the other side, because one's going with the magnetic field and one's going against it.
That's very deep when she said the unlearning is so much harder. That's very deep. It is so true.
Yeah, dude, you're so lucky, Cammy. The ferrocells are awesome. I love this video. Just looking at this hologram is just cool as shit. Like what it, what all you can do with it. And it's like, imagine if you had a ferrocell that you could place space time over and see something, right? Like you'll never see anything like that where they can demonstrate it. And I don't know if you know this, Cammy, but also if you have an electric field, you can produce this effect as well, apparently. So this effect is actually called the Zeeman effect. And then when it's done with an electric field, it's called the Stark effect. So Zeeman and Stark effects respectively. And then, and then obviously they talk about the effects under the paradigm of the photon traveling and whatnot. But yeah, it's very cool. And that's my analysis of what I think is happening with the illumination inside of the ferrocell from the LED ring light.
Oh, we have another podcast. Let's destroy the photon.
Oh, I mean, I put out a video on it. It's dead. I already killed it.
Is it in Telegram on your Telegram channel?
Yeah, it's heliocentric model or heliocentric mythology, the photon vacuum propagation and physical mechanisms. It's here.
Yeah, I'll look at that. I'll look at
Oh,
that
you haven't
tomorrow.
seen it? You haven't seen it?
No, thanks for sending it.
Oh, dude, it's nuts. Yeah, I go over that equation and basically just kind of break that down because they just had to self-invent the ability for the photon to have mass but not have mass, but allow them to calculate mass but not have mass, so that they could say that it propagates through a vacuum.
That's cool. Thank you for sending that. Mm-hmm.
Absolutely, brother. Absolutely. So we'll continue on. I'm glad that I'm not lagging anymore, but now that I've talked about it, I've probably jinxed myself. So.
No, not lagging.
So we'll see how that goes. All right, so here we go for continuing on. Einstein's 1917 theoretical treatment of the uniform acceleration was fruitful in yielding in combination with the equivalence principle, the consequent that light is coming from the surface of the sun possesses a wavelength that is greater by about 2/millionth of a part than the light generated by an identical material on the surface of the Earth. The treatment itself however, was uncharacteristically cumbersome, principally because of the circuitous explanations that the concepts involved. Yeah, so combination with the equivalence principle, the consequence that light coming from the surface of the sun possesses a wavelength that is greater by about 2/millionth part than that of light generated by an identical material on the surface of the Earth. The treatment itself, however, was uncharacteristically cumbersome, principally because of the circuitous explanation of the concepts involved. Despite the explanation, some of the meanings remained obscure. Planck complained that Einstein's concept of uniform acceleration needed clarification since the rate of change of the three velocities is not a relativistic invariant. Oh yeah, dude, Cammy, I love that polarization filter video, that Bell's theorem thing. That's an absolute banger. When I saw that, are you familiar with that, Jim? The two polarized filter.
It's funny what she said. The children get it.
Oh, dude, it. Let me pull this up real quick. Forget about all this Redshift shit. This is boring. Watch this.
I tell you, is she? It's a she, right?
Yeah.
She said.
Yes,
it's a she. She's on fire. The
dude,
unlearning is so much harder.
What is
the children get it?
Yeah.
That's so funny, man. I think I got 2 memes from her tonight.
Dude, wait till you're about to get another one. Watch this. I think it's on her main channel.
You know what we're gonna do? I'm gonna do.
Oh, we can
I'm
do
gonna
it
go.
live. That'd be awesome.
I'm gonna go. The Globers. The Globers think we live on a spinning, watery, curvy, bendy ball, but those of us with brains get it. The children know.
Oh,
The children get it.
I could have sworn I watched it on here.
Oh my goodness. We get it. The flat Earth or the STP children are much more smarter than the Glober adults.
Dang. Was that on your channel, Kimmy? I thought there was a video of it.
The children get it.
Bell's theorem. What's that? 1 minute physics. He has a little video on it too. So check this out, Jim.
That's so funny, man. The children get it.
Dude, you show it to a child, they're like, "Oh yeah, well, light's definitely a wave." You know, when you throw that, I don't do a good job of uploading my channel. That's on here. Ah, okay.
That's funny.
So here's the conundrum, Jim. Here's the let me try and find a good picture of it. Okay. So let's pretend each one of these three circles here. If you could see this on my screen, are you able? Okay, you can see it. Okay, so each one of these three circles is a polarized filter, right? So if you overlap these two polarized filters, the light source will be dimmed out, but light will still get through it, right? No, I'm sorry. When you add one polarized filter, it dims the light source. When you add a second polarized filter, completely blocks out the ability for light to pass through it, right? And then when you add a third filter on top of these three, so that they're overlapping, right? Like in this configuration, you'll never believe what happens, Jim. Would your guess be that the light suddenly magically goes through it, or that light continues to not travel through it because it's being blocked by a third physical object?
Well, you would think that if it stops traveling through a second, it would definitely stop traveling through a third.
You'd think, but here's what happens, and this is what makes it a wave, or what really proves that it's like not a particle at all. Is when they recombine it. Where's the right here? So here we go. Two polarized filters creates this black line here, or this black section here. No light can get through this, right? And then watch what happens when he adds the third one.
Here is asking what would have happened if it was measured at B, assuming that it...
So you see what happened when he inserts
Here
it?
is asking what would have happened.
So for the polarized filter thing, by the way, if you don't know, the lens or whatever blocks the waves all coming in a certain direction or whatever.
I see that.
So if you angle another filter perpendicular to the first one, it will completely block it out. And that's how he creates that that solid black section, right? And then when he throws in that other one, the light comes back through because it's re-amplifying the waves. It's like recombining them or something, and like you can see through it then at that point. And that's crazy because both of these perpendicular to each other are, creating a literal physical obstruction for any sort of photon, right? So yeah, when you put that third one in, it's like, oh, it's a wave amplification situation. There's no photon. But yeah, they actually have like some weird explanation for it, how they get out of this. But it's all retarded. But yeah, that's super interesting. That's what she's talking about. Like even a child can get that. You apply that third filter and it comes back. It's mathematically impossible. Oh yeah, that's right. I forget the mathematical aspect of it, but they actually touch on that in the video, if I remember correctly too. Put that in the link for those who watch it later and stuff. Here's a link to it, Jim. But yeah, when they try to figure out why this is happening, it doesn't mathematically work out. Because if I remember correctly, it's producing more than what both of the reductions are or something. Like obviously that wouldn't mathematically work. But yeah, super interesting.
Got to work in the math, huh?
On the math. Let's see what the comments have to say, if anyone's picking up on this shit yet. I need to watch this a few times and run the numbers myself on the paper to follow it properly, but a brilliant approach in explaining this deeply counterintuitive concept. Really good video. There are 3 polarized lenses. Each lens has 180 degrees of polarization. Yeah. For the filter, or for the entangled photons, 180 times 3. Each lens has 2 sides. The additional polarization equals another 180 times 3. They don't add the 2 sets. Jesus, this dude goes hard. Okay, let's see what you got, guy. Don't add the 2 sets. Instead, remember the entanglement of the photon is being observed. Yeah, dude, the old entangled photon. I can't even read this shit, dog. The entangled photon.
Tangled photon.
Dude, they're just tangled up. Somebody needs to get in there and untangle those photons. It's like take the 180 degree polarization times by 3 filters, divide it by the number of combinations. 3 filters times 3 equals 9. 160, which is 60 degrees. Account for the fail to pass photons. Adding another filter should reduce the light. Exactly. That's what I'm saying. And this dude's like, I guess he's trying to say that it's like a probability of the photon passing through the pole. But see, how would that even matter if the first 2 are fucking blocked? Then it has a 0% chance of passing through. It wouldn't interject. Oh, wait a minute.
We just came up with a new game, Alan. We now have photon foosball, and we have unentangle the photon.
Hold on.
We got 2 games now.
Okay.
We're gonna untangle the photons. Hey, we're gonna use the 3 filter thing to untangle the photons. That's crazy.
Hey, Cammy, if he put this middle one, because originally he has these 2 on top of each other, right? And then he inserts this middle one at a different angle. If he put it on top in the same orientation, but just instead of in between these 2, but on top, it would still produce this lit area, right? Like, that's not what's affecting it, right? Because it still can't do it. I just tried to give him like the most ultimate benefit of the doubt, but I still can't see a way for it to work. Let me just watch this whole section real quick.
22.5 degree angles, the number that get blocked at C seems too high. So let's take a look back at our Venn diagram. What does it mean if one of these photons has some hidden variable somewhere in this crescent moon region plus the C? But if it's impossible, in here that fewer than that, but at the C is coming from the case where the photon was just never measured at B. And all we're doing here is asking what would have
Yeah, see, I forgot about that. So you can actually you can continue to add them, can't you? And it still makes it go up.
So if you add a 4th one, it would make it even lighter.
It starts getting more light starts passing through, which doesn't make any possible sense because the amount that's already blocked, like there's already a reduced amount being blocked from the first one. Adding the second one perpendicular to it completely blocks it. So So the only way I could see how they're getting this, you know, and this is just giving them maximum benefit of the doubt, is no, still can't, because adding more adds more light. It wouldn't keep doing it. I could see it for 3. You could maybe say, like, if it illuminated it a little bit, you could say that no, that the photons, that when he interjects the middle part, that the photons that were getting blocked by this top one are now probabilistically going through this filter because it's not at the orientation to 100% block it. And then from that new orientation bounce or whatever, you know, because it's going to be going in a different direction, according to them, that it would hit this polarization filter and some of the light would come through it that isn't blocked. Because obviously it's still going to block some, and it is lighter than this one. So I can kind of see what they're saying, but that's only if you completely remove any of the physicality of the photon that is required of it to propagate through a vacuum. It would strictly have to be a wave in that regard. Well, no, because it could just bounce, I guess. Because they're doing it based off probability. I've done it with 9 filters. I would have kept going, but I'm not graceful enough. Yeah, I think 4 is sufficient, and then if you add like a 5th and a 6th, like that's pretty much game over. Because with just the 3, they could say, like, they could kind of argue it kind of how I just did by saying probabilistically it's just bouncing off of this one and then it's hitting this one, and there's so many photons, blah blah blah, that it's just working out. But when you keep adding filters and more light comes through, like, that definitely shouldn't work. Like this, it should keep getting darker. Yeah, absolutely. Absolutely. The wavelengths, it should, so if it was working how they're saying it with the probabilistic chance of it being blocked versus passing, and then entering this middle one at a different orientation to the 100% blocking of it by these two, that it would, like, you know, have an effect where it just happens to come through. So if you added a 4th one under their paradigm, it would get darker, not brighter.
So is this 3 filter thing a way to a simple way to destroy the idea that photons exist that are light, that are light part? I mean, a photon supposedly is a light particle, even though it doesn't have mass. That's what they're saying.
Well, they would argue that it's, you know, bouncing through or bouncing off of it, and, like, you know, it's just a probability or whatever. But they couldn't explain that it's getting lighter. It would have to get darker and darker, like at a gradient, getting back to this.
Happened.
It wouldn't, like, because she's saying adding a 4th one, which they don't do in this video, but adding a 4th one actually makes, like, if you add a 4th one to this spot right here, it actually makes it more lit up. Which that right there completely body bags everything that they say to explain just this part. Because with just this part, you could give them the benefit of the doubt. I'm kind of seeing now, with how the orientation of the polarization lens matters, because I forgot that it blocks it, you know, at a certain angle or whatever. So they have to be orientated correctly. So interjecting one in the middle, they could argue that the ones that happen to bounce through this one also happen to bounce through this one, and then that allows them to bounce through this one because they're coming at a different angle than when they originally came through this one to get blocked by this one. So I'm like, okay, whatever. But adding that 4th one increases the luminosity in this region, and that bricks the whole fucking thing. It couldn't do that. Unless, well, wait a minute. Okay, so no, still it couldn't do it. It still wouldn't let more photons in it. I keep trying to give them the most benefit of it. You know what I'm saying? But it's just, I really not seeing it. Yeah, that's awesome.
Yeah,
Totally forgot about that for how the fourth filter and shit, how that applies.
it destroys the photon traveling 13.7 billion miles, 86 trillion, 600 quadrillion miles to reach our eye if it can't make it through a third filter. Kind of destroys that. If I read that right.
Yeah. Do the photons stop being entangled when they pass through the filter? What the fuck is an entangled photon?
It's a new game that you're gonna make up. It's called Entangled Photon. Hey,
What did
hey,
they say? Quantum
we
entangled
have
photon.
we have photon foosball, and we have unentangle the photon. We have two new games.
Yeah, unentangle the photon is like pin the tail on the donkey, but
That's
instead
right.
of trying to pin the tail on a donkey, you're just trying to like undo like a ball of yarn. You know, you're just like unwinding it, I guess.
We got it.
I don't know.
We're gonna start our own games, our own kids games. We're gonna
Yeah.
educate the kids correctly. That's what we're gonna do.
I mean, I hope to educate someone a little bit correctly, or point them in the right direction at least.
I'm gonna use this. I'm gonna go get a picture of this and take it to the debate on Thursday, and say, see, when you add the third filter, it gets lighter, destroys your photon fairy tale. So
Well,
definitely,
you would need the fourth filter, because if they were smart enough, they could argue the third filter within their paradigm if they're aware of it and are intelligent enough to
well,
realize what's going on. Then they could argue. You would need that fourth one, I think, to really nail the coffin. Because once it shows that it's not just letting through a little bit, that it starts to amplify it, like that's a wrap. You know what I'm saying?
yeah. So I'll throw that out there so somebody goes out and does a video on a fourth one. So we'll have fun with that.
Yeah. Oh well, Cammy does it. She'll. I think she has a video on it or something. We could try and get it from her. She's already done all this. You're looking at the polarization filter queen, dog. She's got all the polarization filters.
Yeah, I just want to nail. Boy, I want to nail that photon. Bye bye. It's just like, give me a break.
Yeah, I mean, show them the equations, dog, and just tell them like it's fun trying to extract the physicality required for it to propagate through a vacuum out of that equation is fucking retarded, and it's a reification fallacy. I'm going to bed, but I did accept your invite, and I'm looking forward to talking further. Sweet, awesome, thanks, Cammy. I'll email you tomorrow or something, and just let me know whenever it works for you. We can accommodate. My schedule is pretty much wide open, so whenever you're down and ready to roll, I'm good to go. And look forward to it. You have a good night.
So we can, you and you can destroy the photon, can destroy the gravity, and can destroy the sun. There we go.
Destroy the what?
Destroy the motion of the Earth around the sun.
Oh yeah, I mean, well, they destroyed it themselves. Honestly, they already fudged that one up. All right, so let's.
Can you go and can you imagine going out there and being responsible for killing their quantum mechanics and their relativity? Isn't that something?
No, they'll never really let it go either, because like the parts of it that they calculate that makes a successful prediction, they're gonna hold on to it like the bee's knees.
They will.
So, but there's like a lot that's just completely retarded with it. And a lot of it just has to do with balancing out math equations that they'll later search for the particle that they use to balance out the math equation and say that they found it. That's where it gets really crazy. When they're like, oh yeah, we found this little tiny particle that describes what's inside the electron, or the, I want to say positron, but is that the right word? Not even a thing? Electron, positron? I don't know.
Don't know.
Anyway, Planck, I kind of just feel like wrapping it up, man. After the lag and everything, and
Yeah, we've
and all
been going
that.
almost 2.5 hours.
Yeah, we're almost at our 3 hour limit, and I got some stuff to do tomorrow anyway.
Mhm.
So we can pick up another time. Let's see.
We'll both sit down and we'll make lists of things that we want to discuss going forward, and we'll put our list together and we'll see what we want to do.
Cool. All right. Well, thanks for watching. Hope everyone enjoyed. Hope you got something out of it. Make sure you guys continue to do your own research. Don't believe what I say just because I read it from a PDF written by a peer-reviewed academic system. Find your own PDFs and read them and see if your conclusions align with mine, or if you can draw your own, even better. And then come back and talk to me about what you found, and we could compare notes and figure things out together. Have a good night, everybody. We're going to sign off here. Jim.
Night, everybody.
Night.
Take care.